Hello guys, in this video we are going to discuss the solution of the problem largest square formed in a matrix. So let us look at the problem statement. The problem statement says that given a binary matrix mat of size n by m, find out the maximum length of a side of a square submatrix with all ones. So for instance, in this matrix, the subsquare matrix which is possible here is of dimension 3. That is why we are returning 3 over here. And the subsquare matrix which we are referring to is the green colored subsquare matrix, which is also a square matrix of dimension 3 by 3. That is why we are returning 3 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let's take a matrix. So let us say a matrix mat is given to us, and the dimension of this matrix is n by m, which is n rows and m columns. We are going to take a DP matrix, a dynamic programming matrix of dimension n by m, and each entry of dp I, j stores the maximum squared submatrix, the dimension of maximum squared submatrix, which can be formed using I rows and j columns. So this is the info which the dp I, j stores. So let us try to understand this a bit more in order to understand our solution. So let us say this is my entry dp of I, j. Now if this is dp I, j, or this cell is at location I, j, then that simply means this cell is at location I, j minus 1. This is at I minus 1, j, and this cell is at location I minus 1, j minus 1. And let us assume that these cells have some info which is a, b and c, and a, b, c are integer numbers, and we want to find out the value of dp I, j. So recall from this definition of dp I, j, dp I, j stores the dimension of maximum squared submatrix which can be formed using I rows and j column. So that simply means over here the entry dp of I minus 1 j minus 1, which holds a value of a, this simply means a squared submatrix of dimension a. Similarly, dp of I, j minus 1, the value over here is c. That simply means a squared submatrix of dimension c. And the same goes for I minus 1 and j. And this value is b. This simply means a squared submatrix of dimension b. Now let us assume the value of a is 1, b is 1, and c is also 1. So that simply means the matrix is something like this. This is a DP matrix. So the matrix information is something like this, and we want to populate this information. Now as we can see that this forms a square matrix of dimension 1 by 1. This forms a square matrix of dimension 1 by 1, and this also forms a square matrix of dimension 1 by 1. Now, using this, the maximum dimension square matrix which is possible over here is 2, and that is why we are going to mark it as 2. Let us take few more examples in order to understand the concept. So let us say this is another DP matrix or a portion of the DP matrix, and the values over here is 2 and 2, and this value is 1, and we want to find out the value which we can place over here. Now this 2 signifies that the maximum subsquare matrix which is possible here is of dimension 2 by 2. So that matrix will look something like this. So 2 rows and 2 columns. So let us cover the 2 rows. So these will be the 2 rows, and the 2 columns. So these will be the 2 columns. So in this way, the region enclosed by this subsquare matrix will look something like this. Similarly, when we are saying that this value is 2, that simply means 2 rows and 2 columns. So let us cover that. So this is the 2 row and the 2 columns. So there will be some column over here. Now when we say the value over here is 1, then that simply means it is a squared matrix of dimension 1, which will be only this cell. Now with this information, what is the maximum squared matrix which is possible using all these 3 values? Well, the maximum squared matrix which is possible will be only this much, and that is why over here we are going to fill it as 2. So in a way, what I'm trying to say over here is dp of I comma j will be equals to minimum of dp of I comma j minus 1. So this cell I comma j minus 1 comma dp of I minus 1 and j, which is this cell, and dp of I minus 1 and j minus 1, which is this cell. So the minimum of these plus 1. And in this way, we will be able to populate the entry of dp of I comma j. Let us take one more example in order to understand this concept completely. So let us say this is the portion of the dp table and the values over here is all 2's, and we want to find out the value which we want to put over here. Now let us apply the same logic which we have discussed. This 2 simply means that a squared matrix of dimension 2 by 2 is possible. So the region enclosed by this matrix will be something like this. Similarly, when we say this is of dimension 2, then that simply means 2 rows and 2 columns. So this is my 2 columns and this is our 2 rows. And similarly, when we say that this is 2, so that simply means 2 rows and 2 columns. So this is my 2 columns and this is our 2 rows. And in this way, if you see, the maximum sub-squared matrix which is possible here is this entire matrix, because of which we are going to put the value 3 over here, and that is also equals to minimum of the 3 values which we have. So minimum of 2 comma 2 comma 2 plus 1. So this will be equals to 2 plus 1, which is equals to 3, and this is what we are putting over here. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So we want to find out max square, and a matrix, a two-dimensional matrix is given to us, and n rows and m column is given to us. Now the first thing which we are going to do is we are going to initialize a dp table of dimension n by m, and we will have our answer value with us, and the initial value is 0. Now we are going to iterate on I in range of n and j in range of m. Now over here, if I equals to 0 or j equals to 0, that simply means it is the beginning row or the beginning column. In such case, all we have to do is dp of I comma j will be equals to mat of I comma j. That is the maximum dimension matrix which is possible here, since it is the beginning row and the beginning column, because of which we are updating the value of dp I comma j as such. Otherwise, if matrix I comma j equals to 1, then in such case dp of I comma j will be equals to minimum of the 3 values which we have discussed: I comma j minus 1, I minus 1 comma j, and I minus 1 and j minus 1, and then plus 1. Otherwise, if mat I comma j equals to 0, then that simply means it is not possible to form a squared matrix where all values are 1, because of which dp of I comma j for that entry will be 0. And once we have updated our dp I comma j entry, then we are going to compute the maximum dimension. So if dp of I comma j is greater than answer, then answer equals to dp of I comma j, and then towards the end we are going to return answer, and in this way we will be able to get to our answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So as we have discussed, we are taking a dp table and an answer variable whose initial value is 0. Then we are iterating on the rows and columns of the matrix. If this is the first row or the first column, then dp of I comma j equals to matrix of I comma j. Otherwise, if the value is 1, then we are computing the dp I comma j entry as minimum of the 3 values plus 1. Otherwise, dp of I comma j equals to 0. And then we are computing the answer, which is the maximum value of dp I comma j. And towards the end, we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at our C++ implementation. So the C++ implementation is also the same. We have a DP vector over here of dimension n by m, and the default value or the initial value of answer equals to 0. Then we are iterating on rows and columns of the matrix. If it is a beginning row or a beginning column, then dp of I comma j equals to mat of I comma j. Otherwise, if mat I comma j equals to 1, then dp of I comma j equals to the minimum of 3 values plus 1. If mat of I comma j equals to 0, then the dp of I comma j will be equals to 0. Then we are computing the maximum value in dp I comma j, and towards the end we are returning our answer. So that's the C++ implementation. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.